Hello, my name is Chen. I'm from Team Power. I will present our second project on a system that can connect electricity data and perform data mining and visualization tasks for its users. So first of all, this is an overview of our system architecture. We call the system as a smart meter saver. So it consists of three components. The first one is a database server. And the database will actually stores all the electricity data collected from smart meters which are installed at the different households. And the second component is a web server which will accept user's connection. So when the user wants to view his or her history data, the web server will query the database and return with the result back to the user. And moreover, the users can also specify some tasks they would like to perform on the data set. For example, sometimes they might want to identify the outliers from the data. And in this case, once the system receives such a task, the system will activate the data analysis and mining algorithm. The algorithm itself is implemented in MATLAB, and it is running at the background. So currently the algorithm supports three different tasks. For example, the correct data identification, energy disaggregation, and event monitoring. So for a detailed description of each of the three tasks, please refer to our write-up for this project. So once the system finish the task, the MATLAB server will return the result firstly to the database, and then the web server will retrieve the result and display the result on the screen. Okay, so this is our login page of the system Smart Saver. In order to log into the system, you will need a valid pair of email and password. And once you log in, the page will display the most recent 10 minutes electricity data for you. And in this case, we have three curves actually for three different sensors. And these sensors are all installed in a single household. And the red curve stands for the data sum over all the sensors. And if you want to look into the details, you can drag the slide bar and so that you can change the time granularity. If you would like to go back to some early days, you can specify a time period here. For example, let's go back to December 5th. Okay, for 10 minutes data. So once you submit, the database will return a 10 minutes data for you in December 5th. Okay. So remember that a user can also assign some tasks for the system. For example, if a user wants to identify some outliers in his or her data, they can assign a correct data identification task for the system. And since the algorithm needs some time to run, so in this demo, we will just show you some existing task results on a finished task. So let's go to tasks ID view, which will returns an existing correct data identification result. So in this case, there has several data points. And the higher the value in the y-axis, the more likely the data points might be an outlier. So this is in brief view of the task result. And if you want to assign some new task, you can go to the task request form and fill in this form. So because, for example, you can select correct data identification or disaggregation. And these are required fields for the user to complete. And once the user finishes the form, you can submit to the system. And after the system finishes the task, it will return the result to the database. and the web server will retrieve the result from the database and display the result back to the user. Okay, I think that's all for our demonstration of project 2. If you find this interesting, don't forget to leave some comments below or on the forum. I hope you enjoy it. Thank you for your watching, and I will talk to you next time.